All right, the problem says carry out the following arithmetic operations to the correct number of significant figures. So that's just a fancy way of saying solve all these problems, but make sure your answer is not more precise than the measurements you used to calculate it. So to solve these problems, we have our Sig Fig calculation rules in the top right, and we're going to use those to make sure that our answer is to the correct precision. So looking at A, we have 26.5862 liters plus 0.17 liters. So this is addition. So we're going to be looking at the addition subtraction rule, which says round to whichever measurement is least precise. So which of our measurements are least precise? Well, the precision has to do with how far to the right is our last significant figure. So looking at 26.5862 liters, this 2 here is our farthest sig fig to the right, and it's 4 places past the decimal, so that is in the 10,000ths place. So this first measurement is in terms of 10,000ths of a liter. Our second measurement, we have a 7 here, that's our last sig fig to the right. It's 2 spots past the decimal, and that is in the hundredths spot. So we're talking in terms of hundredths of liters. So not as precise as our first measurement. So that means our answer must be 2 places past the decimal or to the same spot as here. So we could punch this in our calculator, but a good way to kind of see what the precision looks like for each of these numbers is to write them on top of each other, matching up the decimals. So we have 26.5862 liters plus 0.17 liters. So plus 0. Remember, you want to match your decimals up or line them up. 17, and then we end there, and our units are liters. So you can see already that our second number does not go as far to the right as our first measurement. So let's put these in our calculator and add them up, and we should get 26.7562, and then our units are still liters here. But we need to, again, looking at our calculation rules, we need to round to whichever measurement is least precise. So what I like to do at this point is draw a line that is past the last significant figure of our least precise measurement. So I'm going to draw a line, kind of do a dotted line, straight down from there all the way into our answer. So we can see that this digit here is in the same spot as our least precise measurement there. So then we have to round. You look at the digit before and you say, is that going to round up the 5? Well, this is a 6, so yes, that is going to round up our 5 to a 6. So we're going to end up with 26.76, and then our units are liters. So final answer for A would be 26.76 liters. Okay, let's look at B. We have 9.1 grams minus 4.682 grams. So again, we're going to be using the addition subtraction rules. Here we're doing subtraction. So again, we're rounding to whichever measurement is least precise. So let's look at our measurements. We have 9.1. So that 0.1, that's in the tenths place. And then we have 4.682. That too is in the thousandths place. So our first measurement, 9.1 grams, is our least precise measurement. So let's write these on top of each other like we did above. So we have 9.1 grams. I'll put the grams over there because I know what my next number is going to be. And we're going to minus 4.682. Okay, so that is the problem we're doing here, and that's also grams. So if you punch this in your calculator for an answer, you should get 4.418 and then units of grams. Okay, so that's what your calculator says, but our answer cannot be more precise than the least precise of our measurements. So again, let's draw that line. We got the 9.1 and our sig fig stop there. So we're going to draw our line right after the 1 straight down because everything's lined up. So that looking in our answer, we see that 4 is in the same place as the 1. Okay, they're in the 10th spot. So that's where we have to round to. So we got the 1 right to the right. Is the 1 going to round up the 4? It is not, because it is less than 5. So we are going to cut the number off there, and we will be left with 4.4. For our units will be grams. So final answer for B will be 4.4 grams. All right, looking at C, we have 7.1 times 10 to the 4th decimeters times 2.2654 times 10 to the 2nd decimeters. So here we are doing multiplication. So we will be looking at the multiplication division rules. And that says round to whichever measurement has the least number of sig figs. So different rule here. We're looking at significant figures. So for our first measurement, we have 7.1 times 10 to the 4th decimeters. And hopefully you notice that that is in scientific notation, where we have some number times 10 to some power. So being in scientific notation, we know that whatever digits we have first, whichever ones we wrote, they must be significant. Otherwise, we would not have written them out. So the 7 and the 1 are both significant, so we have 2 sig figs for our first measurement. And then looking at our second measurement, we have 2.2654 times 10 to the 2nd decimeters. So again, scientific notation. So the 2, the 6, the 5, and the 4 are all significant. So that is going to be 5 significant figures. So our answer must have 2 significant figures. It cannot have any more than that. So let's plug this in our calculator and see what we get. So we're going to take 7.1, and then I like to use the EE button. So I'm going to hit second and then the comma, which is the EE button for TI-84 or Texas Instruments calculator. So that EE means times 10 to the, so I'm going to put 4. So I have 7.1 times 10 to the 4th. Then I'm going to multiply by 2.2654. Again, I'm going to get the EE button or second comma on my calculator, and that is to the 2nd power, and then hit enter. So we get this great big number, 16084340. So that is our answer that our calculator gives us, but it is too precise. We must only have 2 significant figures. So we're going to take the first 2 digits. So we're going to take the 1 and the 6. Okay, those are our first 2 significant figures, and we cannot have anything more after that. And then we would look to the digit past the 6, which is a 0. And we would look to say, hey, does that round up the 6 or do we keep it the same? Well, 0 is not going to round it up, so our 6 stays the same. And then that digit, as well as all the ones past, are going to become zeros. So we're going to have 160,000,000, or also called 16 million. So we could leave it as 16 million, or, which might be better, we put it in scientific notation. So if our decimal's here, and we're going to go 1, 2, 3, 4, 5, 6, 7 points to the left, we would get 1.6 times 10 to the 7th. And for our units, we have decimeters times decimeters. So that would get us decimeters squared. So final answer for C, 1.6 times 10 to the 7th decimeter squared. All right, let's look at D. We have 6.54 grams divided by, we're doing the division multiplication rule. divided by 86.5542 milliliters. So using division rules, we are looking at significant figures. For our first measurement, we have 6.54. So that is going to be 3 sig figs. And then for 86.5542, those are all significant. They are all non-zeros. So automatically significant. So 6 sig figs for our second measurement. So that means our answer must only have 3 sig figs. Okay, so let's put this in our calculator. We're going to do 6.54 divided by 86.5542. Hit enter, and we get this long decimal here. So we are going to be rounding to 3 significant figures. So we'll start writing from the left, going to the right, and we'll count out until we get to 3 significant figures. So that's going to be, we have 0 point, okay, that first 0 is not significant. 0.0, that 0 is also not significant, so we have no significant figures at this point. And then we get the 7, okay, so there's 1, and then a 5 after that, and then a 5 after that. So there's our 3 sig figs. Now we would go 1 digit farther to see if we round up that third one. So that next digit is also a 5. So we have to stop at this point and ask ourselves, does the 5 here round up our third sig fig? Well, it is a 5, and anything 5 or higher does round up. So we will round our answer to 0.0756. And then for our units, we have grams divided by milliliters. So our units will be grams per milliliter. So final answer for D, 0.0756 grams per milliliter. All right, now for question E, last one. We have 7.55 times 10 to the 4th meters, and that's in parentheses, minus 8.62 times 10 to the 3rd meters. So we have some multiplication in here, but that's just from the numbers that are in scientific notation. This is really a subtraction problem. So we're going to be looking at our addition subtraction rules, and we need to round to whichever measurement is least precise. Now for question E, our measurements are in scientific notation. And although it's easy to tell how many sig figs are in a number in scientific notation, it's not as easy to determine the precision. For example, you might look at these two measurements and say, oh, we have the 5 here, which is in the hundredths place, and we have the 2 here, which is in also the hundredths place. So they have the same precision. But that's not actually the case because they have different powers of 10. In our first measurement, it's times 10 to the power of 4. In our second, it's times 10 to the power of 3. So these numbers have different precision. So there's a number of ways to solve problems that deal with addition or subtraction using numbers that are in scientific notation. One of those methods is to just write them out. Since these numbers aren't terribly huge numbers, that shouldn't be too hard to do. So let's write out 7.55 times 10 to the 4th, not in scientific notation. To do that, we'd move the decimal place 4 times to the right. So 1, 2, 3, 4. So that would give us 75,500 meters. And then we will do the same for our second measurement, except it's times 10 to the power of 3. So we're going to move the decimal 3 places to the right. So 1, 2, 3. So that is going to give us 8,620 meters. All right, so we are going to subtract these numbers, and we will get 66,880 meters for our answer there. But that number may be too precise, so we need to look at the precision of our measurements. So let's underline the last significant figure to the right in each of these numbers. So for 75,500, that 5 is going to be our last sig fig because the 2 zeros past it are not significant. And for 8,620, the 2 is going to be our last significant digit, as the 0 past it is not significant. So now let's draw our line past our least precise measurement's last significant figure. That would be the 5. So we're going to draw the line past that, straight down through everything, including our answer. So that means that this 8 here in our answer, that first 8, is our last significant figure. It's in the hundreds place. So we can only be specific to hundreds of meters in our answer. So we look to the 8, that is the 1 digit past that, and ask if it's going to round up that 8. It is. So we are going to end up with an answer of 66,900 meters. If we wanted to put that in scientific notation, we could do that as well. We would move the decimal place from the right to 1, 2, 3, 4 places to the left. So we get 6.69 times 10 to the 4th meters. So final answer for E is 6.69 times 10 to the 4th meters. All right, there you have it, solving the following operations to the correct number of significant figures. All right, if you want to see another example, click in the top right. Please like this video if it helped you in any way. Feel free to look in the doobly-doo below for additional help and resources. Please subscribe and ring the bell to get notified for new videos. And thank you so much for watching.